Right now, you are floating in the dark, close to a star that is about to die. It is a supergiant, far larger than our sun. If you placed it where the sun sits, its surface would swallow the orbits of the inner planets. And tonight, in a way no human was ever meant to witness, this star is going to explode. For one single instant, it will shine brighter than every other star in its galaxy combined, and you are here to see it. So stay with me. We are going to watch a star die, from up close, together. First, where you are, this is a massive star, born with more than 8 times the mass of the sun, and it has lived fast. A star like ours can burn quietly for 10 billion years. A giant like this races through its life in just a few million. It is so heavy that gravity crushes its core relentlessly, forcing it to burn its fuel at a furious pace just to hold itself up. For most of its life, the star fused hydrogen into helium, and that outward push of energy balanced the crushing pull of gravity. But now the hydrogen is gone, and to survive, the star has begun to burn heavier and heavier fuels, deeper and deeper inside. Here are the warning signs. The giant has swelled and reddened, its outer layers bloated and unstable, shedding matter into space. Inside, it has become like an onion, shell upon shell of burning elements. Helium, carbon, oxygen, each layer hotter than the last. In the final days, the core fuses silicon into iron, and iron is the end of the road. Because iron cannot be burned for energy, fusing it takes power instead of giving it. The star's furnace has run out of fuel. Now watch closely, because what happens next takes less than 1 second. With nothing left to push back, gravity wins. The iron core, about the size of the Earth, collapses in on itself almost instantly. In a fraction of a heartbeat, that core falls from the size of a planet to a ball just a few kilometers across. The matter is crushed so hard that protons and electrons are mashed together into neutrons, the densest matter that can exist. The infalling core slams to a sudden, unimaginable halt, and the rest of the star comes crashing down on top of it. And then it rebounds, a shockwave explodes outward, and a torrent of ghostly particles called neutrinos floods out, carrying almost all of the energy. That blast tears the doomed star apart from the inside and hurls its outer layers into space at tens of thousands of kilometers per second. This is the moment, the supernova, from where you float. The sky itself seems to catch fire. The light hits you in a wall of brilliance. In a single instant, the dying star outshines 100 billion other suns. At its peak, this one explosion can release as much energy as our sun will produce over its entire 10 billion year life. It is so bright that, from far across the universe, we on Earth can see a single one of these deaths with our telescopes. The heat is beyond anything you can imagine. This close, you would be vaporized in less than a thought, before you ever felt pain. But as a witness, suspended just outside, you see the shockwave race past you, a glowing front of matter expanding into the dark. The blast carries the star's outer skin outward in a vast, growing bubble, painting the blackness with color and fire. And here is a wonder hidden inside the violence. In this furnace, new elements are being forged in the explosion itself. Gold, silver, the iron in your blood, the calcium in your bones. Heavy elements like these are born in moments like this one. Years pass, and the fury fades into something hauntingly beautiful. The expanding gas spreads out into a glowing remnant. You have seen these remnants before. The Crab Nebula is the ghost of a star that exploded, a death watched from Earth about 1,000 years ago. Its tangled filaments of gas still race outward, lit from within, a wreath of light marking where a star once stood. Others, like the wisps of the Velar remnant, have spread for more than 10,000 years into delicate threads across the sky. And in Cassiopeia A, you can still see the freshest of these wounds, the shredded layers of a star blown apart only a few centuries ago. But look back to the center, where the star's heart once burned. Something is still there. If the core was not too heavy, it survives as a neutron star, that tiny ball of crushed neutrons, spinning hundreds of times a second. A single spoonful of its matter would weigh as much as a mountain. It is one of the strangest objects in all of nature. If the star was even more massive, gravity does not stop at all. The core collapses past every limit, into a black hole. A point so dense that not even light can escape it. A permanent shadow left where a giant once shone. Now drift back, and let the silence settle. The star is gone, scattered across light years of space. But it is not truly lost. That glowing cloud you watched expand will one day collapse again, to form new stars and new worlds. Every atom of iron, oxygen, and gold in your own body was forged in the heart of a dying star and flung out by an explosion like this. You did not just watch a star die. You watched the universe make the very stuff that you are made of. We are, all of us, the children of supernova, and tonight, up close, you saw one of them give birth to everything to come.